All right, folks, here we go. Here we go. We're live tonight, doing something a little bit different than we usually do. Just fix this real quick. Usually, we play video games on this channel, but the last few streams have been more technically minded. Just got my iced tea. So, the last stream we worked on some software engineering. We're working on some code, embed software for a STM32 microcontroller based board that I've been working on called Vine, part of my Agricultura project. We're going to be shifting gears tonight and be looking at hardware, PCB design, and the software called KiCAD. I've been working on a small project for a friend of mine, and yeah. So I'm going to be working on that for a little bit until I get tired of working on that particular design, and then I'm going to move into working on some more stuff for my Agricultura project, and I'll touch on that more when I get to that part of it. But for now, I'm just going to talk about what I'm doing with the LED board that my friend wants me to design for them, and yeah. So we're going to start try and get things going pretty soon. I want to do another opening song again. I'm not sure how Twitch is going to react to that or how they're going to receive it, but we'll see. I mean, the worst comes to worst is the video on demand will get deleted after the broadcast, and then we will just won't do it the next time. The best thing that can happen is the section of the video will be muted unless I export it to YouTube or whatever, so we'll see. So, yeah. So tonight I want to start us off with an opening song again. This time, it's not necessarily new music, it's just they're not as popular of a group. The band is called Radio Moscow, and I believe they're out of Iowa. They play like a mix of garage rock, classic rock, psychedelic rock, blues-based rock, all mixed together. And yeah, it's really good stuff. It definitely captures the essence of what Jimi Hendrix was doing in the 60s, but with a different flavor to it. And I really like the guitar playing in this particular music and their album. Just like whenever I listen to Radio Moscow, I want to stop whatever the hell I'm doing, pick up my guitar, crank up my amp, and start playing myself. And I feel like that's just a great characteristic of a band, you know, a great quality of them. So without further ado, we're going to take a look at their song I Just Don't Know off their album Brain Cycles. I will put some links in the chat to that to where to get the music and everything about it. So without further ado, we're going to switch gears over to our music music page, and we're going to blast that song. So yeah. Alright, folks, that was Radio Moscow with I Just Don't Know off their album Brain Cycles. I encourage you all to look that up and listen to the full record. Possibly listen to their other records. They're a great band. Definitely sum up the entire sound of the 60s rock and roll sound, both British and American, psychedelic. Really good stuff. Really, really, really good stuff. Dude knows exactly what to do with the guitar and tonally and musically, and I just love it. Absolutely love it. Hope you guys love it too. You definitely want to get out there and support that band. They're a small time group, but they could be a big time group with your help. And I think you really should go check out their music. So, we're going to start things off with some KiCAD work and whatnot. I'm just organizing things on my computer screen right now as we get ready to do some stuff. Um, you know, a lot of stuff going on the computer screen. A lot of I got to pull up my supporting documents for what I'm designing, because the thing a lot of people don't understand about what's it called? A lot about printed circuit board design is there's not much to it, in the sense that a lot of what you have to do in electronic design comes from, what's the word for it? Comes from the manufacturer of the parts you're using. So in this case, we're using a Texas Instrument LED driver and an Arduino micro to do a lot of the work. So we're going to be referencing the documents for those two products. And yeah, so the chip we're using is a LED driver chip designed by Texas Instruments that is a constant current LED driver. So it's basically a DC-DC converter that takes in a large DC voltage and then steps it down to the type of voltage that an LED would expect, a voltage that would drive the LED to a reasonable brightness without damaging the LED. But it also allows us to control the brightness, so it can do a huge range of voltage outputs that make the LED look very nice and illuminated well at different brightness levels. And that's why you want to use an LED driver when you're controlling LEDs, especially when it's for cosmetic reasons. A lot of the times on any board you design, you're probably going to have an LED to indicate stuff, but in the case of this piece of hardware, the focus is to drive and control a couple strings of LEDs. I believe these LEDs are going to be in a reptile's cage, or therefore, I'm actually not sure. I think they're just for like lighting up another project, and I was asked to design a circuit board for this particular circuit. Uh, this converter was selected by another mutual friend of my friends, and that person picked out the parts and kind of like designed the circuit. And then I took their design and I looked at it and I changed a few things and made it possible for this design to be manufactured in the real world and turned into something that actually works. So yeah, I'm just trying to find some stuff to pull up. Yeah, just looking through all my tabs. I have a lot of tabs open, and I'm just trying to pull up the tabs relating to this particular project, and I seem to have found it. So here we go. We are going to capture my screen, and we're going to share the stuff. I'm also going to put some tunes on in the background, and we'll see how Twitch reacts to that. So without further ado, we're just going to go to this. And yeah, this is the board right here. This is what we're working with. So we're going to take a look at the schematic part of it, just because then you'll know exactly what we're talking about. So here. This is the schematic right here for the Texas Instruments TPS 61165 high brightness white LED driver. And that's right here. I'd put myself on this, I'd put my video on this screen, but it would block out a lot of good stuff that I'm working on. Maybe we can work around that. I don't know. We'll see. You know what? Give me a second and we might be able to do that. So we're going to just go over here. Just taking a look at this. That's the whole unit, I'm pretty sure. Just gonna copy and go here. And we're gonna go on top of this. Oh, I just noticed something. My display capture is not showing any of my goodies. Oh no, what have we done here? You're gonna get to see me do stuff live, getting everything ready for you guys live, which is kind of funny. I've done this before though. Hey, we all make mistakes. Don't worry about it. Just let us do this. Pop this guy up here. This way I feel like is the least invasive, so to speak. And then we're just gonna paste and plop my camera right in this thing. Yeah. So we're gonna try this out. Let's see how this looks, everybody. Yeah, it's kind of, I don't know. If anyone's out there watching, do we like this? Do we not like this? I don't know. I'm not sure if I like it or not. So I'm going to get rid of it for now. Anyways, this way we have something going on there. There's stuff on the here. So this is the business end of the circuit right here. This is the chip we're talking about. It's TI. I realized I moved it right here. Here we go. I'm going to read it. It's TI TPS 61165 high brightness white LED driver. We're going to be driving what's it called? We're going to be driving UV LEDs with this, and I think it's for illuminating rocks or possibly a reptile cage. I'm not sure. I just was given a chip to use and some specifications, and I filled in the blanks the rest of the way myself. That's just how I roll. So we're gonna get started with this. So here's the circuit for that chip implemented. You can see an example circuit that they provide in the documentation right here. I started with this, and then I modified made some changes. This is the mutual friend made this this schematic right here, and see, they changed the value of the inductor to 22 microhenries. So I'm assuming they did some changes here and there about that. There's 1 UF farad capacitor. The capacitors and the resistors are basically all the same values. I'm guessing the inductor was swapped out for one that would suit the LEDs better. Anyways, this is what we're working with. This is the implementation of the schematic in KiCAD. I duplicated it so we have 2 separate channels. We're using Phoenix Contact branded screw terminal connectors. We have a 12 volt input power supply. It's going to take a again, screw terminal connectors, some simple decoupling, might add some more stuff for the decoupling, might add a fuse, who knows. I don't think it's that necessary. What we have here is the Arduino Micro board. It has a Atmega 32U4 microcontroller, which has native USB. It's a simple 8-bit microcontroller that has a hardware USB. It's made by Microchip, formerly Atmel. This board is available for about $20 from Arduino. It's a pretty good board to start with. The reason why I'm using this is it's just it's long since supported. The software support is out there. It's cheap. It's dirt simple. AVR chips are known to be industrially robust. If you short them to ground, there's a chance that you won't kill the chip. It'll be okay. So they tend to be really good for industrial applications. They don't have a lot of CPU power compared to other chips that you can get these days for the same price, but in this case it's quick and dirty solution. I wanted to design this rapidly. I banged this schematic out Friday night, relatively quickly. And yeah, so that schematic shits itself out into the PCB right here. And we're gonna have to make a board shape for it. I'm just not sure what I want the board shape to be just yet. I figured I would do the layout for the parts for the DC-DC regulator, which is this right here, the LED driver, to and then I would design the shape of the board, because then I'd have a better idea of how much space it takes up, what shape the copper pores and traces are going to be, and what they look like and how they work. And yeah, so right now I'm just digging through the data sheet, and I can just show you that right here. Typically here we go, layout example. So typically with a lot of these types of chips, LED drivers and DC-DC converters, um, there's a lot of they always have a a layout guide like this, and what this shows you how to do is where to place the components relative to the chip and how to connect them together, and what shape the copper pores on the PCB should look like. And this makes it really easy to do a circuit board design without having a deep understanding of the circuit and the chip that you're using. You can follow the reference schematic and build it, and it most of the time it's gonna work. And that's what's really great about modern data sheets like this. A lot of parts made by electronics manufacturers do this sort of thing where they just document the shit out of their chip, and it's just easy to use. So we're going to be looking at this and following along as we develop our own layout. Now, if you look at this layout, it sort of doesn't match the version of the chip that we're using right now. See, this version of the chip is a SOT23-6 footprint, meaning it's using this is a SOT23 is a common package for a lot of electronic components, and it comes in the standard version is 2 3, so there'd be 2 pins on one side and 3 on the other side, but it can come in a 5-pin form factor or a 6-pin form factor in this case. So that's what we're dealing with, an SOT23-6. I might switch it over to what we're seeing in this document right here, which is a QFN, which means quad flat. Well, not quad flat, DFN, because there's only 2 sides. Dual flat, no lead package, which is a electronic package that has no pins on it and is flat and only has pads on 2 sides. A QFN is a quad flat, no lead package, and that would have pins on all 4 sides and no leads. So I'm just looking through the datasheet some more to see what other versions of this chip are available. Because if there's a yeah, we probably want to use this version of it. Um, yeah, see that. So it's your lucky day. We're gonna learn how to make. Yeah, see, this is a version right here, and these are really easy to solder, those ones, but they're also harder to cool. See, the one with the quad flat package, I mean the dual flat no lead package, it's a lot easier to cool that design because a huge amount of the chip's die is connected to ground, that piece in the middle, and that will allow the silicon on the inside of the epoxy casing to be cooled and less likely to burn out under operation. That being said, Texas Instruments also ships it in the SOT23-6 package, and if they are selling that, then it's good to go. It's gonna work. It's just there's gonna have to be a little bit more consideration taken when I'm making this design. So I'm thinking of going ahead with what I have, just because I've had some success with building DC-DC converters in this type of package before, and yeah. Just taking a swig of my iced tea, and I'm checking stream health because apparently we are experiencing some issues where our frame rates are dropping up and down. For some reason, with Streamlabs OBS, capturing a whole monitor is an issue. So we might try to adjust this. adjust how we're capturing things. Capture a specific window. Select the window. PCB. Okay. And it looks like, yeah, we're stuck using full display capture in this case. So if we're going to have some issues with the stream, hopefully it doesn't screw over viewers. The kind of stuff we're doing doesn't need a high FPS because we're just doing some like slow editing of 2D graphics. So we'll see. And yeah, I'm trying to figure out what the stream health. We haven't been dropping FPSs, but we seem to be oscillating in terms of our frame rate. We're not losing frames, but our frame rate's going up and down. So that is an interesting little factoid. So I'm just gonna get that going over here so that I can monitor our frame rates and stuff. Anyways, we're going to be taking a look at how to implement this particular regulator. I keep calling it a regulator even though it's an LED driver, but the thing about LED drivers is most likely it's a DC-DC regulator on the inside because we need a constant current source to drive an LED. A DC-DC regulator is a great example of a constant current source. So if you look at this, the inductor connects to the input voltage, connects to the switch. You have a Schottky diode connected to LEDs and the switch output. You have a capacitor between the two, and that's connected to the ground. And the LEDs in and out. It's better to see. It's easier to see on the schematic, like the relationship between the components, but this tells you exactly where to place all the parts. So I'm gonna look at that, and I'm gonna do my best my best to implement that. So we're gonna just start doing that. We're gonna crank up some tunes, and we're gonna start rocking and rolling. I think I'm gonna continue with some more Radio Moscow, just because listening to that song really got me in the mood. So sit back and just enjoy the show. We're gonna build this board.